Solving linear equations. What is the difference between an equation and an expression? An equation can be solved. An equation contains an equal sign. An expression can be simplified or evaluated, and an expression does not have an equal sign. So in our first example, which of the following are equations? Circle all that apply. So mainly we are looking for an equal sign. So this first one is an expression. It does not have an equal sign. This second one does have an equal sign. So I am going to circle it. It is an equation. And this last one does not have an equal sign, so it's not an equation. In the next example, we're asked, in the following expressions and equations, how many terms are in each? So in this first example, we have 1, 2, 3, 4 terms. So I'm going to go ahead and write 4. In the next example, the way we currently have this equation set up, this whole thing right here, 7 times the quantity 3p minus 2, this is all one term. And then I have the second term, and on the other side of the equal sign, I have a third term. So this is a total of 3 terms in this equation. And in this last expression here, this is just one term. This is just one term. So what we're looking for is being separated by either addition, subtraction, or by equal signs to find my term. So I'm separated by addition here for my 2 terms, and then I have an equal sign for my third term. And in this first expression, I'm separated by all addition and subtraction. We're going to be working with equations. So in this next example, we're told an equation can be true or false. Which of the following equations are true? Circle all that apply. So in other words, the left side is equal to the right side. So 11 plus 4 is equal to 15, so I do have a true statement. 15 is equal to 15. In the next example, I have 9 plus 10 is equal to 23. So this is an equation, but the left side is 19 and the right side is 23. So this is a false equation. And in the last example, 17 minus 4 equals 13. Well, 17 minus 4 is 13. 13 does equal 13. So I have a true statement. To solve an equation means to find the value or values that make an equation true. These values are solutions or roots. The solution set is a list of all solutions, and these values are listed inside a set of braces, separated by commas if there is more than one. In this example, we're going to determine whether 8 is a solution of the equation. So we want to check whether substituting 8 into each x yields a true statement. So we have 3 times 8 plus 9 equal to 5 times 8. So we're checking whether this is true. Now 3 times 8 is 24 plus 9. 5 times 8 is equal to 40. So we end up with 33 is equal to 40. So while this is an equation, it is not a true statement. So the answer here is no, 8 is not a solution. In the second example, 5 equals m minus 3, we substitute 8 into the variable m, and we end up with 5 equals 8 minus 3, or 5 equals 5, which is a true statement. So the answer is yes, 8 is a solution. In this section, we will work with linear equations. A linear equation in one variable x is an equation that can be written in the form ax plus b equals 0. Now, it can be written in this form, but we may need to do some work to get it there. And a and b have to be real numbers, but a cannot equal 0, because if a equals 0, then we lose this variable x. And to be a linear equation, what we're really looking for is the variable, so in this case x, raised to the first power. Solving a linear equation. To solve a linear equation, we want to get the variable on one side of the equal sign by itself. We call this isolating the variable. Don't forget that what we do to one side of an equation, we must do to the other, so we have to balance the equation. So in the first example, we want to solve the following two-step equations. So for part A, we have 3p plus 7 is equal to 31, and then we're asked to check our answer after solving. So remember that I have to isolate the variable p, but that first means I need to isolate the term 3p, because right now I have this plus 7 that's next to it. So to get 3p by itself, I'm going to need to subtract 7 from both sides. I need to do the inverse operation of addition, which is subtraction. So I'm going to subtract 7, but whatever I do to one side, I do to the other. So I end up with 3p plus 7 minus 7 is going to give me 0. So I just have 3p now is equal to 24, subtracting 7 from 31. So now that was one step. The second step is I need to now get just p by itself. So first it was get the term with p in it by itself. Now I need to get p entirely by itself. Now the operation here is multiplication. So this is 3 times p. So to undo multiplication, I need to do division. So I'm going to divide both sides by 3. That's the inverse operation. And whatever I do to one side, I do to the other side. So now 3 divided by 3 is 1. So all I have left is 1p, but we don't ever write 1p, we would just write p. So p is isolated, and p is going to equal positive 8. So when we have a solution, we write our answer in curly braces. So we have 8 is the solution. And this example asks us to check our answer. So what that means is that substituting 8 back into the original equation should create a true statement. So let's check that 3 times 8 plus 7 is equal to 31. So order of operations, we do 3 times 8 first, so we have 24 plus 7 is equal to 31. And yes, 24 plus 7 is 31. So 31 equals 31. This is a true statement. So we've checked that our solution of 8 is correct. In this example, I have 1 minus 6 over 5c is equal to 13. And we're asked to check our answer. So here we do have a linear equation because I have a variable to the first power. So I want to isolate the term with the variable. So I'm going to need to get rid of this 1. And so since this is a plus 1, I'm going to have to subtract 1 from both sides. So I have minus 1, minus 1. So 1 minus 1 is 0. And so all we're going to have left is negative 6 over 5, c on the left, and 13 minus 1 is 12 on the right. So now, that was the first step. The second step is going to be to completely isolate c. So we isolated the term with c, and now I need just c by itself. So there's two ways I can think about this. I can think about this as absolutely this is multiplication. So I am dividing by negative 6 over 5. So I'm going to write that for a second and just kind of notice that it looks a little bit complicated. So if I divide by negative 6 over 5, I'm dividing inside of a quotient, so this is a complex fraction. So instead of thinking about dividing by a fraction, we're going to use the technique of multiplying by the reciprocal. So negative 6 over 5 has a reciprocal, and that's what we're going to multiply by, negative 5 over 6, but on both sides of the equal sign. So I'm multiplying both sides by negative 5 over 6, and remember multiplication is commutative, so I can write it on the right-hand side here and on the left-hand side here, that's fine. So on the left-hand side, notice that the two negatives will cancel and become a positive. The 5 over 5 will cancel and become a 1. 5 divided by 5 is 1. 6 divided by 6 will also cancel and become a 1. So the only thing that's left on the left is C, which we wanted to isolate. And now we have to simplify the right-hand side. So remember that just a whole number like this is technically that whole number over 1. So this is really 12 over 1 times negative 5 over 6. And now we can go ahead and divide. So I have 6 divides into 12 2 times. So now I have simply 2 times negative 5 over 1. So I have negative 10 over 1. Well, that's just negative 10. So my solution here is negative 10. And I should check my work as indicated here. Now I can always check my work, but this is specifically telling me to. So if I check my answer, 1 minus 6 over 5 times negative 10, does that equal 13? So here we would recognize that I can rewrite this as negative 10 over 1. And then I can perform the multiplication and division here, order of operations, so I can divide 5 into 10 2 times. And the negative times the negative is a positive. So I'm going to end up getting a positive, a plus 6 times 2. So this is 1 plus 6 times 2, that's 12. And 1 plus 12 is 13. So I do end up with a true statement. So we know that negative 10 is the correct answer. In this example, I have decimals involved. Negative 8.85 is equal to 2.1y minus 5.49. Also notice that the variable is on the right side of the equation, but that's okay because I have a variable to the first power, so this is a linear equation. So first I want to focus on isolating the term with the variable. I want to get this term by itself. So I have subtraction next to this term. I have minus 5.49. So what I'm going to have to do is add the opposite operation, the inverse operation. I'm going to add 5.49 to both sides. So what I'll have here is, well, this is a negative 8 and a positive 5, so 8 is a bigger number. We're going to keep the sign here. So this is going to be a negative. It's going to be negative 3.36, and then this is equal to 2.1 times y, because the negative and the positive of the same term is going to give us just 0. Then I have negative, or 2.1, not negative 2.1, 2.1 times y. So I'm going to divide both sides by 2.1. The inverse of this multiplication is division. So dividing both sides by 2.1, I end up getting negative 1.5 is equal to y. So my answer is negative 1.5. And although we're not told to check our answer, we absolutely could. We can go back in and substitute negative 1.5 into y and perform the order of operations to make sure that the left side equals the right side. In the next set of examples, we have a little bit more to do to solve these linear equations. I want to be clear though, this is a linear equation because although I have more terms involving x, each of those terms simply is x to the first power. So this is a linear equation, but to solve, what I'm going to have to do first is I'm going to have to combine like terms on each side of the equal sign first. So 2x minus x, those two like terms, are going to combine together to be just x, and then I'm going to leave the plus 5. On the right-hand side, the like terms are just the constants, so I'm going to combine the 7 and the plus 2. So I have 3x plus 9. So now what's different is that I have still remaining two terms involving x. So what I need to do is get those terms involving x to one side of the equal sign and all the terms not involving x to the other side of the equal sign. So I'm going to choose to try to get all my x terms on the left. So I already have an x on the left. If I want to get this 3x to the other side, I'm going to have to subtract it from both sides. So I can't just simply move it. That's sometimes what students try to do. I have to subtract 3x from both sides to balance my equation here. So I'm going to do minus 3x minus 3x. So 3x minus 3x is 0. So these cancel out. I end up with just 9 is equal to, now on this side, this is a 1x minus 3x, so a negative 2x. And then I'm just going to bring down the 5. So negative 2x plus 5 is equal to 9. And now this looks a lot like our two-step equations from earlier. So now I want to get this one term with x in it by itself. So I'm going to do the inverse operation of addition here, subtraction, subtract 5, subtract 5. So I have negative 2x, the 5 and the minus 5 becomes 0, and then this is equals 9 minus 5 is 4. Now here, sometimes students mistake this for subtraction because they see this negative 2, but this is negative 2 times x. So to get the x by itself, I have to do division. So I can't add the 2 to the other side because it's not being added, it's being multiplied to x. So I'm going to divide by negative 2, divide by negative 2. So now the negative 2 over negative 2 just becomes a 1x. So I have x is equal to negative 2. So my answer here is negative 2. And to clarify, I could check my work as well. I could go back up to the original equation and substitute a negative 2 into each of the x's and simplify to make sure I have a true statement. In this next example, I have some grouping symbols. So the first thing I need to do is remove the grouping symbols by distributing. So I distribute in the 2. I end up with 2 times 1 is 2. Minus 2 times 3h, that's 6h. And then I have to distribute the negative 5 to both terms. So negative 5 times 2h is negative 10h. And negative 5 times positive 3 gives me a negative 15. And this equals negative 21. At this point, I can combine like terms on the left side of the equation. So I can combine my negative 6h and my negative 10h. So combining by adding the coefficients gives me negative 16h. And then I can combine my constants, 2 and negative 15. Those add together to give me a negative 13 is equal to negative 21. So at this point, I want to isolate my only term with the variable, that's negative 16h. So to isolate this term, I'm going to add 13 to both sides of the equation. Because then negative 13, positive 13, adding together equals 0. So I have negative 16h only is equal to, now here, 21 is the bigger number, so I keep the sign, so I have a negative 8. I have a negative 8. And then here, to get h by itself, remember this is negative 16 times h. So we're going to need to divide by negative 16 on both sides of the equation. So we're going to have those negative 16s divide and become a 1 and leave us with simply h is equal to, let's reduce this fraction, the two negatives cancel and give us a positive, and 8 over 16 becomes 1/2. 8 goes into 8 once, and 16 is divisible by 8 and goes in 2 times, so I get positive 1/2 as my solution. Let's look at another example with grouping symbols. So again, we want to go ahead and remove the grouping symbols by distributing. So we want only terms added or subtracted. So we have 2 times x, 2x, and then 2 times negative 1, we have minus 2, and then we'll bring down the plus 3. And now we have is equal to x, and then this negative 3 will distribute to both terms. So we have negative 3 times x, that's negative 3x, and negative 3 times 1 is negative 3. Now on each side of the equation, let's go ahead and combine our like terms. So on the left side we have 2x, and then we can combine negative 2 plus 3 is positive 1 plus 1. On the right hand side I have this 1x minus 3x. So that's going to give me a negative 2x minus 3. Alright, so now I have done as much as I can to each individual side, but yet I still have two terms with the variable in it. I have a 2x on this side, I have a negative 2x on this side. So I'm going to go ahead and choose to move my variable terms to the left-hand side. So, and by move, I mean I have to do the opposite operation here. So I have a minus 2x, I'm going to have to, or a negative 2x, I'm going to have to add 2x to both sides. I'm going to add 2x to both sides. So the negative 2x plus 2x is going to give me just 0. And I'm going to bring down the minus 3 that was there. On this left side, 2x plus 2x is 4x. And I have to bring down the 1, so I have plus 1. And now I have just one term with the variable x. So once I have just one term with the variable x, that's when I want to isolate that term. So I'm going to subtract 1 from both sides. I need to do the inverse operation. This was addition, I have to do subtraction. So I'm going to subtract 1 from both sides. So I have 4x, the plus 1 minus 1 gives me 0. And then negative 3 minus 1 is negative 4. So I'm going to go ahead and bring my work up here. I have 4x is equal to negative 4. So the last step, this is 4 times x, is to divide both sides by 4. So 4 over 4 becomes 1, and I have just 1x, or x, is equal to negative 1 as my solution. And now we reach some examples that are going to involve fractions and decimals. So we're told here, solve by first clearing fractions or decimals first. So I have 3/5 x is equal to 2x over 3 plus 5. So we can see that our coefficients involve fractions. So what we can do is we can find the least common denominator of all fractions involved. So between 5 and 3, the least common multiple between these two numbers is 15. So that's the least common denominator. So I'm going to go ahead and write that the LCD is 15. So what we do is we multiply each term. We multiply each term by the LCD 15. So we have 15 times 3 over 5x is equal to 15 times 2x over 3 plus 15 times 5. So each term, even if it doesn't involve a fraction, so even the 5, gets multiplied by the LCD. So now, at this point, what we can do is simplify. So here, this is 15 over 1. So I can divide 5 into 15. I can reduce. So I'm going to go ahead and do that. So 5 goes into 5 once. 5 goes into 15 3 times. So this first term here is 3 times 3, or 9x, is equal to, here this is 15 over 1 as well, so 3 goes into 3 once, 3 goes into 15 5 times, so I have 5 times 2x, that's 10x, and then here I have 15 times 5, so that's 75, so I have plus 75. So this equation is the exact same as solving the original equation, but notice that it doesn't have any fractions. We've cleared the equation of fractions, but it's the same because we just did what on one side what we did to the other side. We multiplied everything by a 15, so that didn't change anything. So now we'll go ahead and subtract 10x so that we get our variables on the left side. So I'm going to subtract 10x, subtract 10x. So 10x minus 10x cancels, so I get 75. And then 9x minus 10x is a negative x. Now here, I can't stop. I need just x, not negative x. So what I have to do is divide by a negative 1. There's a negative 1 being multiplied in front there, so I have to divide by it. So I end up getting x is equal to negative 75. 75 divided by negative 1 is just negative 75 as my solution. Here we have another example, and this one includes some fractions and it has some grouping symbols involved. So before I do anything, I'm going to clear fractions. So I'm not going to remove grouping symbols. I'm not going to distribute this 2/3 in or this 1/4 in. I'm going to go ahead and clear fractions first. So all of my fractions, I have 2/3, I have 1/4, I have 1/2. I have to look for the LCD, the least common denominator, for all three of those fractions. So the least common multiple between 3, 4, and 2 is 12. So the least common denominator is 12. So I have to multiply each term by 12. Now there is one term here. Remember, this whole thing is one term. Then I have another term, so 3 terms on this side, and then here's another one and another one. So a total of 5 terms need to get multiplied by 12. So we have this big long equation now. So all I've done is put a 12 in front of each term. And then we're going to go ahead and simplify. So we have 12 times 2x, that's going to give me 24x. And then we're going to simplify this 12 times 2/3. So the 3 divides into 12 4 times, so I have minus 8 times 5x minus 6. So the 12 doesn't also apply to the 5x minus 6. It's just multiplied by this number here in front. Minus 12 times 10, so that's minus 120, is equal to, so here 12 times 1/4, so 4 goes into 4 once, 4 goes into 12 3 times, so we have 3 times 3x plus 1. Then finally plus 6, because I'm going to divide 2 into 12, goes in 6 times, so we have plus 6. So once we've cleared all of our fractions, this equation is going to be easier to solve. Now I'll distribute in to clear my grouping symbols. So I'll distribute in the negative 8, so I have 24x minus 40x. I have 8 times 5, that's 40, so minus 40x. Now negative 8 times negative 6 is plus 48 minus 120 is equal to the 3 distributes, so 9x plus 3 plus 6. Now we'll collect like terms on the left-hand side, so 24x minus 40x is minus 16x, negative 16x, then minus 72, combining 48 minus 120, is equal to 9x plus 9. And now we're going to need to get our 2 remaining x terms on the same side of the equal sign. So I'm going to subtract 9x from both sides. So subtract 9x, subtract 9x. And we're going to go ahead and get negative 25x minus 72 is equal to just 9. The 9x minus 9x is just 0, so we wouldn't write that. So let's go ahead and bring this up here to finish this out. I have negative 25x minus 72 is equal to 9. So I just have one term involving x to isolate. So I'll add the 72 to both sides. So I end up with negative 25x is equal to 81. And then finally, I will divide by negative 25. Remember, I don't add 25, I divide by negative 25. So I end up with x is equal to negative 81 over 25. And remember that that negative can stay in the denominator, it can move to the numerator, or we can write it on the outside. So this is my solution. And there's no need to rewrite it as a mixed fraction or convert it to a decimal. We would leave it as an improper fraction.